past couple of lessons, we have been working with slope-intercept equations. So we introduced the outline for a slope-intercept equation, what goes where, and you were practicing graphing them or looking at a graph and taking them off of the graph. Today we're going to work some more with slope-intercept equations. We're actually going to keep working with them tomorrow as well, so we'll be working with them all week. The lesson yesterday and today and tomorrow are things that you need to know. They actually are 8th grade level skills that are things that are going to really help you to know going into algebra and high school math next year, but they're not in your math book. So no book is perfect, and every book chooses to include some things and not others. So your book chose not to include this, which is why your lesson title says Lesson 9.5 Extension, because this is actually an extension of what's in your book. That you need to know, which is why we're taking the time to do it, so that when you get to high school next year and you see it, you know what to do with it. So we're going to work a little bit more with slope-intercept equations today. So first of all, just a quick reminder. So we know that the equation or the outline for slope-intercept form is y equals m times x plus b. And this is where we drop our slope in, and this is where we drop our y-intercept in. So you were using that yesterday when you pulled that information off of the graph and then dropped it into the correct slots in the equation. Now, this works all well and good when we actually have the slope. I just realized I forgot the c and intercept. When we have the slope and the y-intercept. But sometimes we might have information about a line where maybe we know the slope and the information we're starting with is some point somewhere else off on the line that's not the y-intercept. And that's what we're going to talk about today is if I have the slope and a point other than the y-intercept, how can I use that to figure out the y-intercept so that I can write my equation using my outline? So first of all, just a quick review. So we already know that if we know the slope and the y-intercept, we can write the equation. So this is basically what we were doing yesterday. This first example would be information that has already been pulled off of a graph. So this would be kind of like after you'd pulled it off the graph, writing the equation from yesterday. So if we know the slope is -2 and the y-intercept is 5, then all we have to do is take our outline and just drop things into the correct spots. So the slope goes into the slope spot and the y-intercept goes into the y-intercept spot, which gives me a finished equation of y equals -2 times x plus 5. And the x and the y, remember, those stay in x and a y in the finished equation because that's where you would put an input or where you would get an output if you wanted to calculate using your equation. And that's something that we are going to work with next week is once we've learned all the different things about writing these equations, we are going to practice using them so you can see how they're used and what they're used for. So that's kind of what you were doing yesterday. So today we're going to put a little variation on that. So like I was saying a minute ago, in some cases we might know the slope and we have a point. So remember, the y-intercept is a point. When we say the y-intercept is 5 on a graph, that would actually be 0, 5. So it is a point or a coordinate on a graph. So we might be given a coordinate that's not the y-intercept. And if it's not the y-intercept, I can't put it in the y-intercept spot. I have to figure out what the y-intercept is first. So it might be a situation kind of like this. Write the equation of a line that has a slope of 1/2 and passes through the point 1, 8. Well, that's not the y-intercept. So I cannot drop a 1 or an 8 into the y-intercept spot because that's not where the line crosses the y-axis. So I have to figure out where does it cross the y-axis. So the way we could figure that out is to basically take everything we do know and fill it into our outline. So if we take our outline, so we do know that the slope is 1/2. So we can put that in its spot, into the 1/2 spot. And then remember, the x and the y, those are inputs and outputs. But every time you're given a point, you're being given an input and an output. So this is basically telling you x is 1, y is 8. So if I put in a 1, I get out an 8. So we can fill that into the equation and basically say, okay, 1/2 times an input of 1 plus something is supposed to give me an output of 8. So you see where we took the x and put it in the x spot, and then the y and put it in the y spot. You have to be really careful. Make sure you get the x in the x spot and the y in the y spot. Don't accidentally get them reversed and fill them into the wrong places. Otherwise, you'll get a wrong answer. So from here, we could work backwards. We could say, okay, so 1/2 times 1 is 1/2. So 1/2 times something, or 1/2 plus something, is supposed to equal 8. So that's a one-step equation. So if I work backwards, minus 1/2, 8 minus 1/2 is 7.5. So that is my missing y-intercept. So this graph, if you were to graph it, it would hit the y-axis or meet the y-axis at 7.5. So that's what I mean by fill everything in that we know. So we can fill in the slope. If you're given a point that's not the y-intercept, that point is an input and output. You can fill the x into the x spot and the y into the y spot and then just work backwards, because with everything else filled in, the only thing that you're going to be missing is this y-intercept, which means you can work backwards and figure out what it is. So it would look just like the process would look exactly like what we just walked through. And then the last step, remember we went through all this work to figure out the y-intercept, but we haven't actually written the finished equation yet. So now that we know what the y-intercept is, we have to go back and say, okay, so we already knew that the slope is 1/2. Whoops, I meant to do a highlighter there. We already knew that the slope was 1/2, and we just figured out that the y-intercept is 7.5. So those are the two pieces of information that we would normally use to write our equation. So now that we actually know both of those things, we can go back to our outline again, drop the slope into the slope spot, drop the y-intercept into the y-intercept spot, and our finished equation is y equals 1/2 times x plus 7.5. So that is our final answer. So don't forget, after you do all of this work, working backwards to figure out what the y-intercept is, you have to take that last step and actually write the final equation. So what you are going to do today is some practice problems to just practice walking through these steps. So you're going to have some problems that are very similar to this example problem. Basically, it's going to be the example problem with the numbers changed. So you can practice the process and just make sure you know the process and that you're comfortable with how the process works.